Hey math kids, today we're going to look at combinations and permutations in the context of story problems. So on number 1 it says a random sign generator produces signs that begin with 2 letters. If the possible letters are P, Q, G, and X, how many different permutations of these letters can be made if no letter is used more than once? So right in the problem it tells us it's a permutation. So when we're setting this up we're going to do a P. Now there's 4 possible letters and we have 2 spots to place those letters, so it's a 4P2. We come over here, use this formula, and so we get 4 factorial over 4 minus 2 factorial. That gives us 4 times 3 times 2 times 1. The bottom is really just a 2 factorial if we simplify it, so it's 2 times 1. If we cross out the 2, cross out the 1, we end up with 12 possible outcomes for that one. Okay, the next one, it says, in how many ways can a president, treasurer, and secretary be chosen among 5 candidates? So we know there's 5 and 3, and since there's specific titles, that would create a different outcome. So, for example, if I have president, treasurer, secretary, and I have student number 1, 2, and 3, but maybe a different outcome involves those same 3 students, but that's a different outcome because if 3 is the president, that's different than 1 being the president, okay? And that would just, go on. So since order matters, we have a permutation. So we use the same formula we used on the last one, 5 factorial over 5 minus 3 factorial. So that's 5, 4, 3, 2, 1. 5 minus 3 is 2, so that's going to be 2 times 1. So that's really a 2 factorial. The 2 and the 1 cancel. 5 times 4 is 20, times 3 is 60, and so we end up with 60 for that final answer. Okay, on the next one, it says, in how many ways can a group of 5 players on a varsity boys basketball team be chosen from a team of 14 players? So it's going to be 14, because that's how many we choose from, and we are choosing 5. Now, because there's no specific positions mentioned or anything like that, we're going to assume that order does not matter, and that's why this will be a combination. So if we use this formula, we get 14 factorial, 5 factorial, 14 minus 5 factorial, and let's do a little bit of simplification. So that's a 9 factorial right there. So the top is going to be 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Then on the bottom we have 5, 4, 3, 2, 1. Then we have 9, 8, 7, 6, 5, 4, 3, 2, 1. So right here is 5 factorial, right here is 9 factorial, 5 and 9 factorial. Now, all of these cancel, so that's good news. And now I'm just going to go to a calculator. I'm going to just find the top of that fraction, which I've already done, 14, 13, 12, 11, 10. And I get that number. Then I'm going to do 5 times 4 times 3 times 2 times 1 to get the bottom. And now I'm going to take 240, 240 and divide that by 120. And that gives me 2002. Okay, so the answer to that one, there are 2002 ways to make that happen. All right, we are almost done. One more problem. How many ways can a group of 3 students be selected from a class of 10 students? So we're choosing from 10, and we are choosing 3. And since it doesn't tell us any detailed information about the students, like positions or place in the class or anything like that, it's a combination. Order does not matter. So we're going to use that same formula as last time. We're going to get 10 factorial on top of 3 factorial, and then 10 minus 3 factorial. So that becomes 10 factorial over 3 factorial, and then this is 7 factorial. So I get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then the 3 factorial is 3, 2, 1. And the 7 factorial is 7, 6, 5, 4, 3, 2, 1. All the way from the 7 down, cancels out. Go to the calculator, do 10 times 9 times 8. So that's the top of our fraction is 720. The bottom, 3 times 2 times 1 is 6. And if we just divide 720 by 6, we end up with 120. So the answer to number 4 is 120. If you need additional help, please come to Math Lab. Until then, calculator.